quite sound the same on an acoustic guitar, does it? Hello and welcome to Underdog Physics. Today I'm going to cover some basics of waves, sound and amplitude. When I pluck one of these strings, it vibrates. The mass per unit length of the string and the tension, among other things, dictate the kind of sound I get, but I won't go into that detail right now. The reason I can hear the guitar is that the vibrating string transfers energy to the surroundings. This energy causes the body of the guitar to vibrate, the air inside, the air outside, etc, etc. So long as there is some kind of material in between the string and where it's going, the sound will continue to spread outwards. The reason I can eventually hear the sound is because those vibrations go into my ear and vibrate my eardrum, sending a signal to my brain. Nice chord. Horrible. When I pluck the string gently, the amplitude of the vibrations is small. Take a look at this animation. This animation shows the string vibrating. It's a standing wave, which is what you get when a transverse wave bounces back and forth between 2 points. For example, on a guitar string. The vibrating string causes surrounding wood and air particles to vibrate back and forth, which makes the neighbouring particles move back and forth, and so on, eventually reaching my ear. The smaller amplitude vibrations means that my eardrum vibrates with a small amplitude. It's so quiet. It's so loud! That's all for now. Thanks for watching. Please feel free to like, share and subscribe. Can't even play my own song. This energy causes the body of the... This energy...